There we go. We're going to look at specifically the property whenever we have parallel lines. So angles and parallel lines, very exciting. In the diagram, transversal T intersects parallel lines M and N. So I'm going to start out by labeling this N, because M is labeled but N is not. And it tells us that they're parallel. So I'm going to draw in my little triangles to denote that they're going to be parallel lines. Okay. So let's go ahead and list our corresponding angles. Our corresponding angles are going to be angles 1 and 5. They're in the same position. Angle 1 and angle 5. We're going to have angle 2 and angle 6. And you don't want to really memorize the numbers because they'll change. It just happens that these are the same as the other page. Angle 3 and angle 7, and then angle 4 and angle 8. Now I want you to take a look, and if you want, maybe cut out a piece of paper equal to this angle. This angle here is rather wide. It looks like it's maybe like 100 degrees. It's more than 90, you know, so it's not a right angle, it's a little bit more than that. So we said angle 1 and angle 5 were corresponding. Let's take a look at angle 5. Isn't this one also look like it's about 100 degrees or more than 90? Don't they look like they're the same like width, the same dimension? They should, because they are. They are exactly the same. This angle is the same as this angle. So what we find is when we have corresponding angles, the two angles that are corresponding to one another are equal. They're equal in measure. Okay, so let's take a look now at our alternate interior angles. We have, this is our interior, so our alternate interior are going to be 3 and 6, angle 3 and angle 6, and then angle 4 and angle 5. Same thing is going to play here. These are going to be equal. These ones are a little bit harder to see unless you actually cut a piece of paper out or something. But angle 5, I'm sorry, was this wide one, a little bit greater than 90 degrees. You said like maybe it's like 100. This one here, angle 4, although it's a different orientation, it's kind of upside down. This one is also a little bit greater than 90. Same thing, about 100 degrees. What you can do, if you want to see for sure that they're the same, is go and take like a piece of paper and cut an angle that matches, like put it over top of this here. Put an angle that matches this angle 2, for instance. And cut it so that it's like a point like that. And then go ahead and see if it matches the other angle. See if it matches 6 because they're corresponding. Or see if it matches something else that it's supposed to match. And you'll find that it does. And that's a nice way to prove visually how it works, so you can see it easier for yourself. Or come see me because we'll do that in class. Next, alternate exterior angles. So they're on the outside. Our alternate exterior angles come to be angle 1 and angle 8. And then we have angle 2 and angle 7. These are equal as well because we have parallel lines. So the property here is that when you have parallel lines, your alternate interior pairs are equal with what they pair up with. Same with your alternate exterior as well as your corresponding. So let's take a look at example 2. In the diagram, transversal T intersects parallel lines M and N. If the measure of angle 1 is 75 degrees, find the measures of the other numbered angles. So we're going to find the measure of angle 2, angle 3, here we go again. Measure of angle 2, measure of angle 3, measure of angle 4, all the way down to the measure of angle 8. Now what I'm going to ask in this problem, and you're not going to have to do this for every single one, but I'm going to go through whenever I explain this and explain why they are what they are and write it in. Typically though, if you're asked to find the missing values, you can just write them in unless the directions say to explain or justify your reasoning. So let's take a look. Angle 1 is 75 degrees. Well, I can say that angle 2 is going to be 105 degrees. And the reason I'm saying that is because angle 1 and angle 2 are supplementary. So if this is 75, 75 plus 105 is 180. 180 minus 75 is 105. So that's how I find what angle 2 is. They're supplementary. So because angle 1 and angle 2 are supplementary angles. Okay, now let's see what else I know. Ooh, 2 and 3 are verticals, so this has got to be 105 as well. 2 and 3 are verticals, so 105 because angle 2 and angle 3 are vertical angles. Oh, well, if I'm on that track, let's just go with this. Angle 4 is 75 degrees also. because angle 1 and angle 4 are vertical. So angle 1 and angle 4 are vertical angles. Alrighty, now let's move on down to the second bottom segment. I can say that angle 5 is going to be 75 degrees. And I can say that because a couple of reasons. I can say angle 5 is 75 because it's alternate interior with angle 4, or because it's corresponding to angle 1. So because it's alternate interior with angle 4, or it's either alternate interior, here's the interior, or corresponds with angle 1. Corresponding to angle 1. And I'm really abbreviating it here since I'm writing it on the computer. Next then, since I know 5 is 75, I can state confidently that 6 is 105 because angles 5 and 6 are supplementary, totaling 180. Then we have, I can say that angle 7 is 105 degrees because angle 6 and angle 7 are vertical. And I did not have to go in order, I just did. And then the last one is 8, which is going to be 75 degrees. And there are a number of reasons. Again, these are only some of the explanations. 75 could be because it's corresponding to angle 4, it's supplementary at angle 6, it's supplementary at angle 7, it's vertical to angle 5, or it's alternate exterior to angle 1. And that same situation applies for a lot of these. There's a lot of reasoning, so you don't have to put every single one. I'm only going to put because it is alternate exterior to angle 1. Ooh, there we go. I wrote ATL. Alternate exterior to angle 1. That's why that one works. But again, there's a number of reasons like I just went over. So when we see it like this, we see there's like a nice little pattern. It goes 75, 75, 75, 75, 105, 105, 105, 105. So if you find the two angles that make the supplementary angle, then you're pretty much done as long as you have the right two angles. Don't jump the gun. Make sure you add and subtract correctly. Alright, example 4. Find the measures of the numbered angles in the diagram. So they're telling me that this is 80 degrees. So there we go. This is 80 degrees. So 3 is going to be 80 degrees also because it's vertical. Then angle 1 and angle 3 are supplementary, so this is going to be 100 degrees. And angle 1 and angle 2 are vertical, so that's 100 degrees. Now I can say, okay, 2 and 5 are alternate interior. So this is 100 degrees. 3 and 4 are alternate interior as well, so this is 80 degrees. Then 4 and 7 are vertical, so that's 80 degrees. 5 and 6 are vertical, so that's 100 degrees. I check my pattern, 80, 80, 80, 80, 100, 100, 100, 100. There we go. And again, don't always rely on the pattern. Make sure you're understanding why it is what it is. Letter B, 122. Well, these 122 and angle 1 are supplementary, so 180 minus 22 is 58 degrees. Okay, then 1 and 2 here are supplementary, or I can say 122 degrees is vertical to angle 2, so this is 122. Angle 1 and angle 3 are vertical, so that's 58. I can say that angle 3 and angle 4 are alternate interior angles, so that's 58. Angle 2 and angle 5 are alternate interior angles, so that's 122. Then I could say, well, 1 and 7 are alternate exterior, so that's 58. Or I could have said that they're vertical angles, or corresponding angles. And then 6 is going to be 122, because again, alternate exterior to this up here, corresponding to this, supplementary to these two, or vertical to angle 5. A number of different options. Alright, last example.